Inshallah, in today's class, we are going to continue to find the particular integrals of linear equations of higher orders. In the last class, we have seen how to find the particular interest when the function is e power ax. Today, let me see sine ax or cos ax. When we get the function in terms of sine and cos, when we get the function in terms of sine and cos, then the method will be d square equals to minus a square. D square equals to minus a square. Suppose if f of minus a square equals to 0, we cannot do because 1 by 0 will be infinitely not defined. So in that case, the method is multiply numerator by x. Same that of previous. Multiply numerator by x and differentiate denominator with respect to d. And differentiate denominator with respect to d. One more thing here we have to learn is what is the difference between numerator d and denominator d. And if you get d in the numerator, that means it is the differentiation d by dx. If you get d in the numerator, it is nothing but d by dx. But if we get d in the denominator, that means it is the integration 1 by d. Whenever you get 1 by d of some function, it is integration of f of x, integration of the function. So let me do few questions based on these methods. So this is, let me take this 2. See here, few questions are there on the board. Let me start with the first one. What is your find? Just we are not solving the whole question, we are just finding the particular integrals. How to find the particular integrals we are seeing. So let me do the first question. Bring d here on the right side, 1 by d square plus 1 into sine of 2x plus 3. Just now we have seen the method. When we get sine or cos, the method is we have to keep d square equals to minus a square. In place of a, what we are having, compare like this sine x. So in place of a we are having 2, so this will be minus 2 square. Minus 2 square is 4. Therefore particular integral is yp equals to 1 divided by, in place of d square we have to write minus 4 plus 1 into sine of 2x plus 3. So what is the next step? Sine of 2x plus 3. What we are having, minus 4 plus 1 minus 3. Let you write minus on the numerator, minus 3. So this is the first question. Let me try for the second question. Let me try for the second question. Now the second question is, see here, second one. Bring this d on the other side, you will be having y equals to 1 divided by d square plus 4 into cos 2x. Now watch carefully. If we put d square equals to minus a square, that is minus 2 square minus 4. Here a is 2 cos ax. But if we keep here minus 4, if we keep here minus 4, minus 4 will plus 4 will become 0. So 1 by 0 is infinitely not defined. For this, we know what is the method. Multiply numerator with x. Multiply numerator with x and differentiate denominator with respect to x. Sorry, with respect to d. And differentiate denominator with respect to d. So this is the method when you get f minus d square value is 0. If you are getting 0, then we have to change. Therefore yp equals to, you multiply numerator with x, 1 into x will be x. Differentiate denominator with respect to d. This is constant 0. D by dx of d square will be 2d, so this will be 2d into cos 2x. Now just now I explain you yp equals to x by 2, we write as it is x by 2. We just already learned just now that 1 by d means integration. 1 by d means denominator, we are getting d in the denominator, that is differentiation in the denominator means integration. 1 by d means integration of cos 2x dx. Now let me continue this one, x by p. So x by 2, integration cos will be sine, integration of cos will be sine. Integration of cos is sine dx. But with x we are having 2. But with x we are having 2. In integrations, if we have some coefficient with x, we have to divide by that. So this 2 should be divided. Now what is left here? X by 4 sine 2x. So therefore particular integral is x by 4 sine 2x. X by 4 sine 2x. Now let me try the third question also. So what is the third question? What's here? Now let me solve the third question. See, bring d there on the right side. What is left here? Y equals to 1 divided by d cube plus 1 into cos of 2x minus 1. Now what is our method? We have, let me change a step. You see here, let me, okay, what is the method we are having? We have to substitute d square equals to minus a square. Compare cos ax, in place of x a we are having 2, so this will be minus 2 square. This is minus 2 square is 4, so we have to substitute d square equals to 4 minus 4, but we are having d cube, so change the d cube. We can write like this, d square into d, so this will be d square is minus 4 into d. So what will be here? Therefore, particular integral is yp equals to, we solve this one, 1 divided by d cube can be written as minus 4d, minus 4d plus 1, minus 4d plus 1 into cos of 2x minus 1. Now, see here, in denominator we are getting d, but we cannot substitute d. We have the formula d square for d square, not for d. So to make this d into d square, we must do the method like rationalization. You are having a minus b, you multiply with a plus b. This will become a minus b into a plus b, a square minus b square. Then we will get d square, then we can substitute. So for watch carefully, this is step. You write the plus term first, 1 minus 4d. We have to make this d square. Unless we make this d square, we cannot change, okay? So to make this d square, we are having a minus b, multiply with a plus b, multiply with a plus b, that is 1 plus 40 in the numerator also and in the denominator also, 1 plus 40. Okay, now what is left here? Cos of, because our method is we have to use d square equals to minus a square. In denominator we don't have d square. To make this d square, multiply this with a minus b, multiply with a plus b. Okay, now you see here in the numerator what will become? If you multiply 1 into cos, will be cos of 2x minus 1, plus you multiply 4 into d, cos of 2x minus 1 divided by, once more you ask, 1 into cos will be cos, 4 into cos. Now denominator becomes formula a plus b into a minus b is a square minus b square. 1 square is 1 minus b square, 4 square is 16d square. Again we can substitute here, d square equals to minus a square minus the value of a is 2 square minus 4. So in place of d square we can substitute minus 4. Next thing you see here, cos of 2x minus 1, we don't have to change, right as it is, but here we are having d. D means d by dx, d in the numerator means d by dx, so we have to differentiate this. So d by dx of cos will be minus sine and 2x will be 2. I'll explain you. You write this as it is, cos of 2x minus 1, you see here 4 as it is. Now d by dx of cos is minus sine, d by dx of cos is minus sine 2x minus 1, but we are having with x2, if you do internal differentiation, 1 is constant 0, d by dx of x is 1, 1 into 2 will be 2, so you write 2 also here, right, 2 also here. So denominator what we have to write? In denominator 1 minus 16 into, this is minus 4, b square is minus a square. So let me stop here the last step. Therefore yp equals to, see here, minus into minus plus 60, 16 4 or 64, 64 plus 1 65. Let me write like this, 1 by 65 into what is here, cos of 2x minus 1 minus 4 to the 8 sine of 2x minus 2. So this is the method to solve when questions are given in sine and cos. Let's see here next question, y double solve. Solve means we have to find both complementary function and also particular integrals. And what does it mean? We have done many questions on this also. When these conditions are given, then using these conditions we have to find the constant c1 c2 when we get in the answer. So let me start with the question first. You see here, this is nothing but d square, y double dash means d square plus 4y dash means d plus 4 into y equals to c3 sine x plus 4 cos x. Now to find complementary functions we take auxiliary equation. What is auxiliary equation? In the place of d we have to substitute m square plus 4m plus 4 equals to 0. Okay, see, this is the quadratic equation. If you take these values from calci or you factorize 2 into 2, you will get m2 values minus 2 comma minus 2. Since both values are repeated same values, we have to use case 2 for complementary functions. Therefore, complementary function is yc equals to c1 plus c2x into e power mx. Those who have not seen the part 1, those who don't know about the complementary functions, I request them to see the part 1 where I explained how to find the complementary functions. Okay, this is the case too. When both values are equal, you have to use this formula. If you want to go in detail, you go into the part 1. Okay, so let me substitute the value of m here. M is minus 2. Sorry. So we get the value of c1 as c1 plus, sorry, yc as e power mx minus 2x. So we got the complementary function. Now for particular function, we have to bring this d on the other side. So what we have to write, y equals to 1 divided by, let me substitute the value, d square plus 4d plus 4, d square plus 4d plus 4 into 3 sine ax plus 4 cos x. For sine and cos, we have the method d square equal. Now you see here, sine ax, compare what is the value of a, 1. Compare with cos ax, what is the value of a, 1. Suppose here 1, here 2, we have to separate both and solve. Here we have to give a equals to 1, here we have to keep equals to 2. But since here both are 1, here also 1, here also 1, no need to separate, we can solve by using, no need to separate the terms, we will put this as it is and solve. So what is the method we are having? You have to substitute d square equals to minus a square. So in place of a, both here we are having minus 1 square, so minus 1 minus 1. So let me substitute d square value minus 1. So what we will get, see here, watch carefully, yp equals to 1 divided by, if you keep d square minus 1, 4 minus 1 will be 3, 4d plus 3 into 3 sin x plus 4 cos x. Now next step, just now we have done, if we get d in the denominator, we cannot substitute, we have to change this into d square. So multiply this with its rationalizing factor a plus b, means we have to multiply with a minus b. So therefore yp equals to 1 divided by 4d plus 3. So we have to multiply with 4d minus 3 to bring d square in the denominator, 4d minus 3. Okay, into, you write this as it is 3 sin x plus 4 cos x. Now see here, watch carefully, in the numerator let me multiply the two terms. If you multiply the two terms, this will be 4d into this one, 4d into 3 sin x plus 4 cos x. Finish. Now you multiply with minus 3, minus 3 into 3 sin x plus 4 cos x. Now divide by, now this is a plus b into a minus b, a square minus b square. A plus b into a minus b is a square, means 4 square 16, d square minus 3 square is 9. Now what does the mean d here? In the d in the numerator means differentiation. We have to differentiate this, d by dx of sin is cos, d by dx of cos is minus x. Let me differentiate this one. Let me multiply with minus 3. You see here I am writing 4 as it is. Now d by dx of sin is cos, so this will become 3 cos x. Cos will be minus sin, to plus into minus, minus 4 sin x. Minus, you multiply minus to plus, minus 9 sin x. Minus into plus, minus 12 cos x. Divide by, now again we have to substitute in place of d square. In place of d square we have to substitute minus a square, means minus 1 minus 9. See in the denominator what we are having, minus 16 minus 9 minus 25. I am writing like this, minus 1 by 25. We have written this one minus 25, so this is minus 1 by 25. Now multiply this, 2 3 4s are 12 cos x, minus 4 4s are 16 sin x, minus 9 sin x, minus 12 cos x. So let me cancel this one, plus 12 cos x minus 12 cos x cancel, minus 16 minus 9 minus 25, minus 1 by 25 to minus 25 sin x. So sin x will get cancelled, minus 1 is plus sin x. So therefore yp we got sin x, yp we got sin x. Let me add this to, now see here I wrote few steps. We got already yc previously and we just now we got yp. So the complete solution is y equals to yc plus yp. Yc we got this plus yp. We cannot leave this here because the conditions are given. Using these two conditions we have to find c1 and c2. What is the first condition given? y of 0 equals to 1. That means x equals to 0, y equals to 1. This is x value, this is y value. So let me substitute x equals to 0, y equals to 1, y equals to 1 means this is 1. If you keep x equals to 0, 0 into c2 0, e power 0 1, 1 into c1 c1. Sine 0 is 0, therefore we got the value of c1 equals to 1. In next condition is given y dash of 0 equals to 0, but we have to find y dash now. So let me first differentiate and find y dash. Differentiate. Because here also we are having x, here also x, so when we differentiate we have to use uv. Now y differentiation is y dash. What is uv? U d by dx of v plus v d by dx of u. U means c1 plus c2x d by dx of v. D by dx of e per x will be e per x again. But minus 2x differentiation is minus 2. X is 1, 1 into minus 2, minus 2. Let me write this here. Plus, no, u d by dx of v plus v. V means e power minus 2x d by dx of u. C1 is constant 0. D by dx of x is 1. 1 into c2 will be c2. Plus d by dx of sin x is cos x. D by dx of sin x is cos x. So let me substitute now the values. What are the value we have? We are having y dash of 0 equals to 0. That means x equals to 0, y dash equals to 0. Now substitute y dash equals to 0, this will become 0. E power 0, 1. X is 0, so c2 is 0. What is left here? Minus 2 into c1, minus 2 c1. This becomes 0, this becomes 1. Now see here, e power 0, 1. 1 into c2, c2 plus c2. Now cos 0 is 1 plus 1. Now let me substitute what is c1 here. Just we got c1 as 1. So substitute 1. 0 equals to minus 2 into 1 plus c2 plus 1. Minus 2 plus 1 is minus 1. If you bring minus 1 on the other side, it will be plus 1. c2 equals to 1. So we got this c1 and c2. We have to substitute the question. What is the solution? C equals to y equals to c1 plus c2 x into e power minus 2x plus sin x. We got c1 value 1 plus c2 is also 1. 1 into x e power minus 2x plus sin x. So let me complete the part here itself, because this type of questions we have done every type methods one time. Inshallah, in the next part we will going to continue, inshallah, the other type of questions, inshallah. So I request you to share this and to subscribe this and link with your friends also. One more thing is, you practice 2-3 questions of the same type so that you will get the perfection. Same type questions, you practice 2 or 3 questions more, then you will get the perfection in this topic. Inshallah, we are going to continue in the next class, inshallah.